Hello, geometry students. This is Mr. Martin. This video is going to cover some topics from Chapter 0. We're going to be talking about some basic vocabulary to get started with, and then we're going to get talking about some symmetry, which is going to be important for the course. So let's dig right in. Anytime you have questions or if you missed something, go ahead and pause the video, and if you need to, rewind the video. Those are good skills to use while you're watching the videos. Pause, rewind, rewatch. And then if there's anything you still don't understand when you get to class, go ahead and write down those questions in the margins of your notes and ask them when you see me or your teacher in class. So the word geometry is made up of two separate Greek words. We've got geo, which comes from the word earth, and we've got metry, which is for measure. So basically this was a way for people to measure their surroundings, what was around them, parts of the earth. So it began as the study of the earth measure. People like the ancient Egyptians used geometry for reestablishing land boundaries after the yearly flooding of the Nile and building the famous pyramids. So can you think of any other words that have geo as a root? So go ahead and pause the video and write down some words that you can think of that have the root geo, and we'll make a list of those when we get back to class. Alright, so hopefully you came up with a few words that have geo as a root. Let's go ahead and talk about the actual definition of geometry. So it is a branch of mathematics concerned with the properties and relations of points, lines, angles, surfaces, and solids. So in this course we're going to have a lot of vocabulary, and in order for you to be successful you're going to need to know all the words. Some of these most important ones are in this definition: points, lines, angles, surfaces, solids. We're going to be studying all of these. Alright, so again I'm going to ask you to pause the video and think about where we can find geometric shapes in art, nature, the real world around us. Pause that video and go ahead and see if you can come up with some, and we'll discuss those when you get to class or when you see me. Alright, so moving on to symmetry. Symmetry is when one shape becomes exactly like another if you flip, slide, or turn it. So basically we're trying to figure out how we can make one shape exactly fit over another shape by doing something to it, like our flip. Okay, flipping it over, or we could just slide it from one place to the other, or turning it, or we'll say rotating it. All right, so there's a bunch of different kinds of symmetry. So let's talk about a bunch of these. We've got line of symmetry. So line of symmetry is a line that when an image is folded over the line, the two halves match exactly. All right, so if we're going to think about a picture, let's look at a triangle. So here's a very simple case of a figure that would have a line of symmetry. So if I folded this triangle over that dotted line, the left half and the right half would match exactly. All right, so why don't you go ahead and pause the video and see if you can draw a different picture that has a line of symmetry, and go ahead and draw that line of symmetry in. All right, next we have reflectional symmetry. So sometimes we'll call this mirror symmetry. So mirror symmetry does involve our previous definition of a line of symmetry. So this definition that we used up here, a line of symmetry, let's fix that typo over there, is going to be involved in reflection symmetry. So reflection symmetry is when you can fold an object along a line of symmetry. Okay, so we're going ahead and we're using that other vocabulary word in this definition. So reflectional symmetry, an example may be a heart. Okay, and then that would be our line of symmetry, but this heart has reflectional symmetry because we can put that line of symmetry in the middle and the two halves are the same. All right, so moving on to bilateral symmetry. So bilateral has two parts here. We have bi and lateral. Bi meaning two, and lateral meaning sides. So bilateral symmetry, this is actually a special type of reflectional symmetry. Okay, so for bilateral symmetry, this is when an image has exactly one line of symmetry. Okay, so these two examples that we looked at before, these both have bilateral symmetry. They only have one line because, let's look at another example of reflectional symmetry. If I draw a rectangle, this would actually have two lines of symmetry. I can divide it this way, or I can divide it this way, and each of these dotted lines divides the rectangle into exact halves. So for bilateral symmetry, it has to have only one line of symmetry. For example, this stick figure has exactly one line of symmetry. It has bilateral symmetry. So go ahead and pause the video and see if you can draw another figure that just has bilateral symmetry. All right, so rotational symmetry, our last type of symmetry, is when an object looks the same after you turn it around a point less than 360 degrees. Okay, so for example, if I look at a star, draw a star in here. Again, anytime you need to pause the video, feel free. And if I pick a point right here in the center, the way I want to determine if this has rotational symmetry, we have to visualize. If I take this point here and I rotate the whole star around the point in the middle, once that point reaches this spot, the star is going to look exactly the same. Okay, and then we could rotate it again till the point got over to here, and again the star would look the same. And we could rotate it one more time, and one more time here, and then eventually it would come back to the top. So we could rotate this 1, 2, 3, 4, 5 times, and each time we got it to one of those other points, the star would look exactly the same. This has rotational symmetry, and eventually we'll talk about how to determine the number of degrees of rotational symmetry. So maybe start thinking about that. And again, if you want to go ahead and pause the video and come up with another example of a picture for rotational symmetry, go ahead. Otherwise, we are at the end of this video. Again, if you had any questions, make sure you ask me or your teacher next time you see me or them in class. And we'll see you in the next video.